So I thought today we'd take a look at a piece of gear that I picked up at a Hamfest about a year ago. It caught my eye. You know, I do have a thing for this older gear. I honestly have no idea exactly what it is. It's got a Radar Electric tag on it here, as you can see. Radar Electric was a big supplier here in Seattle. Really, before I moved up here in '97, you know, I've heard the stories. Apparently, it was a great place to go look. This is obviously manufactured by Leeds and Northrop, Philadelphia, made in the USA. It's got this great little meter movement on it. I'm not sure what the meter movement is indicating. Nice little control knob on it. A couple of inputs labeled standard, BA, plus and minus, and X. At this point, you know as much about it as I do, although I suspect a few viewers will be able to say, oh, that's a blah, 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 and tell me what it is. I look forward to comments to find out more about it. There's not a lot to see on the backside. It's unit number 920. There's 6 flathead screws, which give a hint to the age. Up on top is this tag that it was calibrated, 1/28/1953. Which gives a hint as to what it is. The fact that it has a calibration sticker in 1953 says to me it's some kind of piece of test gear, most likely. So let's go ahead and open it up, see what we find inside. There's the 4 nice flathead screws on the unit with the nice color around them. So these beautiful screws have been removed to it. They're flathead. They have a beautiful patina to them. Just a nice old screw. Coming back to look at the unit, there's these 2 controls. I think they're controls. One's labeled GA, the other one's up near this BA. Sorry for the shadow. And these are spring-loaded. I can push them up and down. You might be able to hear the spring inside doing something. At first I thought maybe they were like a pressure terminal. They do have a little indicator on top that you know, it does seem to rotate through 180 degrees. Change the hands over to this one. This one freely rotates, but it doesn't have the indicator dot on it. And again, they both depress. It'll be interesting to take a look inside and see what the mechanism is on those. And of course, we have some kind of a variable control. Based on the sound I hear inside, it sounds like it's probably a wire-wound potentiometer. And of course, we have this meter over here with some kind of a knob on it, and a little button here, not really a button, it just says clamp and points at it. Let's go ahead and open the guy up, take a look inside, see what we have. It's always fun doing this with one hand while you were holding the unit with another hand. So there we have a look inside. I see several interesting items. The first thing I notice is these little push button controls I notice are actually switches. So there's a nice little switch mechanism there. This one is the one that freely rotates. It's interesting. Let's take a look at the other one. Let me spin the unit around so we can see the switch. And we'll take a look at what it does. So depressing the switch, you can see that it activates the switch, and when I rotate it, the rotation actually locks it in the closed position. So it can be locked closed, or it can be allowed to act as a switch. Pretty mechanism. Looks like it's probably a phenolic material again. I don't think it's Bakelite, but it could be. It's really pretty. Up here on the top where the binding posts are, there's several buses wired between them. There's this large outer bus that runs from the outer negative terminal to the inner red, I'm assuming positive terminal there. There are what look like 2 inductors, most likely. They look like they are coiled wire and have been dipped in some kind of a resin. There is this beautiful potentiometer. Based on the sound, I guess it was a potentiometer. And as I look at it and rotate it here, It certainly is a potentiometer. It looks like there's actually two independent potentiometers. Is that correct? Yes. We come back out here a bit and point out the parts. We have essentially the pickups here that run against these two outer wheels. Here, they come back and are independent, picked up and fed back to the switch here. I don't know if the video will pick this up, but when I look at the silver resistive elements around the outside of this, they look like very tightly coiled springs. I am assuming they are a resistance wire that has been wound tightly and sits around the body of the mechanism. If I rotate it back around to here, you can see how those are terminated, and there is a screw assembly that holds them both in place. They run up against these two pickups. I get a nice satisfying sound of a high quality wire wound resistor. I find this interesting. It's got this little coil of wire that comes out of the unit, and as I spin it, you can see those move. Those come up to these two, what I'm assuming are inductors. I'm assuming those are the other side of the resistive element. These are probably fixed to one end or the other end up here. And then we have the pickup, of course, that picks off and brings it back around to the switch. Over underneath the meter movement, we have what I am assuming is a horseshoe magnet. It's slightly magnetic. Oh yes, definitely a horseshoe magnet here. Sorry about the shaky video. Definitely a horseshoe magnet. So we've got this nice horseshoe magnet here. We've got some kind of a metal block there in the magnetic field. Let me see if I can get some light in there. See if I can read this. It's always fun finding sufficient light. So looking down at that tag on the side of it, it says catalog number PI24C, and then below that it says coil resistance 2.50 ohms. I'm really curious what this guy here is. The body of it is not magnetic. I'm guessing some kind of a non-ferrous material, maybe aluminum. It kind of looks like aluminum oxide is formed on it, though I could be wrong. That large can comes up to this knob here that says Leeds and Northrop Company on it. I'm assuming it's some kind of control. I don't know if you can see this on the edge of the knob. There is a slot with a screw head in it that controls the rotation to 20 degrees or so. I'm assuming that is moving some kind of an element inside of that metal box, which I would assume is influencing inductance, or I just don't know. We come around to the meter movement itself. It is held in place by that brass crossbar and the brass screws that run through the front panel, which of course ultimately holds this meter movement in place. The meter movement of course says made in USA, and it's got a scale that runs from essentially -15 to +15. I don't know what this was meant to measure. I have no idea thus what it was used for. I'm guessing somebody who sees this video may instantly say, oh, that's a whatever. It would be interesting to know. It's just a beautiful piece. Is what it is. Get a little better look at this calibration sticker. Calibration 12853, OK. And it looks like somebody's initials, DHT. There's a couple pieces of Scotch tape holding that on the box. I don't know if this comes out of Radio Electronics when they were making stuff. I don't know if it was supplied by them. It's got that build quality where, you know, it's got the nice routed edges around the case. It's got a nice finish to it. Just a really beautiful little box. So there you have it. Still don't know exactly what it is or what it was used for. Just an interesting piece. It is on display in my entertainment center, along with all kinds of other electronic doodads and oddities that I have picked up. We will be looking at a few of those in a future video. Just a beautiful old piece. Hopefully somebody can tell me what it is.